Okay, good morning guys. Welcome to our channel once again, eaudemathematica. Okay, so as you have understood by viewing thumbnail and the description, and the title of this video, on what topic I am going to discuss today with you about. Yes, this is written on the board. So the video is going to be really crazy, I assure you. So don't forget to smash like button, and yes, obviously also smash this red icon, subscribe, yes, and please share this video to your friend as much as you can, and as many as you can find. You can actually make your friends to know about this kind of topic and about this channel information, which is really wonderful. I always bring for you this kind of topic every day. I try. Okay, so without wasting any more time, let's jump to the discussion. So as you all know that this e to the power pi versus pi to the power e, and which is bigger, you all know, almost all know, who are actually very efficient in calculus, actually who are reading in BSc first years. Obviously we know, because in 11-12 we have understood how to solve this kind of problem. Okay, but the problem is what you have know, that you have tried this kind of problem with the help of differential calculus. Yes, but the heading is I have shown you that this kind of problem can also be handled by integral method. So how is that? First what you know, but many of you have forgot what is this by differential calculus, but let's have a quick review how we can do this. So let's have a quick review of that. Okay, let us make a quick review. So we have to find out that, you look, it is by pi, and we have in the other hand pi to the power e. As it is? Yes, as it is. But in this kind of case, we consider a function like x to the 1 by x. Okay, so we found that to be our f of x. Okay, and in this case we differentiate our f dash x, and once we have differentiated our f dash x, we get such kind of thing, I think. Yes, am I right? Oh, I'm sorry, I'm not right, almost. If you differentiate, you would get this kind of thing. Okay, once again we have minus 1 over x squared, then we have to have something like no, 1 over x squared minus 1 over x squared ln x, and you come out this 1 over x squared a factor 1 minus ln x. This is, and how I have differentiated in one junk. Okay, I'll just hold the camera a little bit that you can see this. Okay, finally, so that is the idea almost. But then you have to find how I have do this in just one way, and just one chance. I'll show you in the description below. This is a very fine trick to do this kind of exponential differentiation in a fine manner, very quick method, without assuming any log function or anything like that. Okay, so just do that. I have assumed log function in my mind, but this is very fast. Okay, I will show you. If I got time in the later of the video, I could show you, or otherwise I would give the link in the description. Okay, so no matter. So you can see that then I have do for x less than 0, for all you can see that 1 minus ln x is less than 0, but that is x is greater than e. Fine, that means x is greater than e. But when x is greater than e, then, and you also find that if x is equals to e, okay, so this function assumes highest value, maximum value. How you found that? You found this f double dash x and you put f double dash e, and you see this is less than 0, which means if it is less than 0, I'm sorry, I think it would be greater than 0, and this is greater than 0, you get a peak like that, a maximum. If it is less than 0, it would be minimum, I think. I'm sorry, it is a maximum, so it is less than 0. Forget, sorry. Whatever, okay. But I am not showing you that. But as you know that, as you once know that, so you just put. Then you know f of e is the maximum. Yes? As f of e is the maximum, then f of, obviously this would be greater than any other value of, it assumes, like f of pi, and that is very easy then by this definition of the function, and you just rearrange. We have to come up with the solution. Okay, that is cool. That's really cool. But this is the well-known method that all know. But what is the tricky method that I have given in the description? So let's check it out. So to do this thing, just for doing this thing, what do I have to do? As in the case of differentiation, you know, you have assumed a function like x to the 1 over x. In this case, which is f of x obviously. So in the case of differentiation, so let's say g of x, which we would use in the case of integration, would be of the form 1 by e minus 1 over x. Okay? Now, why I have assumed this? Why you have assumed this in the differentiation, you know, because you can find that if I put e to the power pi or some function, this I don't know firstly, so I can use this, then I rearrange this guy a little bit. We can find it may be greater than, less than, or maybe equal, whatsoever, we don't know firstly, suppose. Then we use pi to the 1 over pi. Then what you can see that you have a similarity all over there, e, pi, pi, so you can have this kind of function in your mind obviously. But why I have found this kind of function in integration? But that's a case, that's a really wonderful case. I will talk to you later in the video why I have assumed. Okay, for this now I'm just showing you how to make this function in our help, or how to make this function to help in our video to make the solution. Okay, so let's see how we can actually use this, actually make the most of it. So what we have to do, we have to integrate our g of x to e to pi. We'll integrate this, and you know integration is really easy, so just do the integration quickly with respect to x obviously. So what is our integration? Just the quick review, you know, the integration would be like, okay, x over e minus ln x e to pi, you know, no problem. Then you use pi over e minus ln pi, but whenever you use e, there would be minus the form e over e minus ln e, but you know this is 0 because ln e is 1 and e over e is 1, so I just left a little bit ln e, so this is just pi over e minus ln pi. Cool, so far so good. But now the one thing which is really wonderful here, that the thing is that you can find that your function over here g of x, is it positive or negative when x is greater than e? As I have integrated over e to pi, so x is obviously greater than e. it is touching E and also greater than E. So greater than or equal to actually E and less than or equals to actually pi. So x is actually varying in the range, and you know in the integration you can also remove the equality sign because one point does not change, just only one point does not change the value of the integration, you know, because we have a whole function. If we remove just a thin line, this has no area, so it does not increase never or decrease never anything if we add or remove this one line which has zero area. Okay, so this is easy. That is so far so good. And now, as you know that, what I am talking, as you know that if x is greater than E, then what happens? Then you see that this function over here is always positive, because this function, if x is greater than E, so it is smaller than 1 by E, and 1 by E minus something smaller up to pi or up to anything bigger than E, greater than E, it is always positive number. Yes, agree with me? To check it, to remove this. So remember the result, this is the result. Okay, just remember, keep it in your mind, the integration result that is needed later. Okay, I am not erasing this. Okay, this I am talking to you about here. So g of x is always greater than 0 for all x is greater than E. Yes, so you know integration is area under the curve. So if a curve is always positive, so it integration or area should be always positive. Actually 1 by E minus 1 by x, which is g of x, this graph is actually looking like this. Okay, this is actually 1 over E and this is actually E. How I have find out? So I would make another video to trace curve more efficiently, more easily by just observing. I have just traced the curve just by observing. Okay, no matter, don't forget, that's what I am saying you. So greater than E, this is always positive as you see, but less than E, this is negative in this position, but no matter. But then the area that we had found up to pi would always be a positive number. As you see, we divide it into some smaller rectangle or whatsoever we do, height, base, all are positive, so area would be positive no matter. So the integral result over here would also be positive. So pi over E minus ln pi is positive. Cool. Then we rearrange this guy a little bit. I mean pi over E greater than ln pi. Cool. Then we take the E there. As you know, as E is in the base, over the pi the power, and if we take both sides ln E, that will just give you E to the pi greater than pi to the power E, and hence with a very much easier way I have proved the result. So the video is up to that. Thanks for watching, guys. I hope you have loved this video and hope you would think like me like that. But okay, I have actually promised you to assure you why I have actually used this kind of function assumed. So I think that would be again a big video, but no matter, I want to tell you, discuss you about. So you see, whenever we have a function, we as I have used in the case of differentiation, we have assumed like that I have shown you. But when you have e to the power pi is greater than pi to the power e, then what I happen, I take everywhere log, both side log, so this looks like this. The same thing, that the reverse process that I have done now, but this is the idea generated. So actually this is the straightforward process for generating my idea, then use this process. Okay, so you just divide this and take this, bring forward, this is greater than 0. But as you see, this and this is same, so I think I would use the fact that I would use here x, they are also x. Then I differentiated this and you get that the result is. That may be the process that you can find out, and you have to show that this is always positive, then this is always positive by the integration. So the area and the curve, everything that works in that guy's mind, and so actually I want to say you that this is not my idea. This idea is my teacher's idea, coaching teacher. So I want to give you the link in the description of his website. His website is also like me, WordPress website. You can follow, you can find many kind of interesting blogs from this site. That is really wonderful blogs. So there I have found this kind of idea, but the basic idea, but he has actually worked from this kind of base. But I thought how I can show you how this idea come. So thinking, I have find out, yes, that is the all rigorous process that how the idea generated in his mind. Maybe it is generated in his mind or others, but he has just worked from this process. But I tried from this process and come to this and get satisfied that yes, the idea comes like that, not comes very surprisingly. Okay, so this is a very wonderful, brilliantly actually thought, manipulated. Okay, really good. So thanks for watching today. This is enough for today. So before I take goodbye, I want to tell you, as you are seeing me on my face, I am wearing mask. Still, it is not needed that I am just wearing this for the awareness. It is very not necessary to wear you for when you are in home. Okay, so when you go out, please wear masks and stay home, stay safe. And obviously we are in a really very much bad condition. We know we are in lockdown. Anyone is not getting very much interested in lockdown. They are going come out and gathering, but this is not the motto. Mainly we have to actually work with all of us. We have to save our family, not only our family, we have to work for the greater interest of the biggest family. The biggest family is our world's family. Okay, so please till then be safe, and obviously don't forget to check my videos. Not my videos, you can check any videos in the YouTube interested in maths, okay, which are really concerned in maths. If you love maths, it would be easier. You don't be depressed if you love maths, because math is such a thing that actually would be in your mind and make you think for many idea, and it would absorb you in this thing, and your time would be passed. So thing is that you have to pass the time by staying home, so that is a great idea. Thanks for watching. Till then, be safe. For the next video I am coming soon, so till then be safe, stay home, stay safe. Sabdhan India. Goodbye.